let's look at covalent compounds. So remember, covalent compounds are compounds made of two or more nonmetals. So the ones that are over here on your periodic table only. If you know you're doing covalent compounds, you only have to look here. Save yourself the time. All right, so let's start off with a simpler one. Let's do fluorine. Actually, so some of our elements are something called diatomic, which means that they will bond with themselves. So let's do fluorine, which will bind with itself, and I'm going to show you why. So fluorine looks like this. I've drawn fluorine a lot today already. 5, 6. There we go. 9 electrons. Move over here so you can see me. So it wants one more electron. Fluorine doesn't travel by itself. Here's another fluorine atom hanging out over here. And this fluorine has the same problem. It also wants one electron. So what covalent compounds do is these nonmetals will come together and they will share a pair of electrons. So there's a pair of electrons that is actually in both of the fluorine atoms. So what that looks like is this. The way we draw it is we overlap the shells of the two fluorines. So I'm going to draw another here. There's fluorine. It has 2 on the inside. Okay, I'm going to put this one over here. So this fluorine's actually, I'm going to draw this fluorine's in another color so you can see. Let's do red. So 1, 2. So this fluorine, its valence electrons or electrons in the outside shell are in red. See how there's still 1, 2, 3, 4, 5, 6 valence electrons, and this one has 1, 2, 3, 4, 5, 6, 7 valence electrons. But this pair of valence electrons in the middle is being shared between both. So now both these fluorines are stable, and that's how you draw a covalent. Didn't write it. Bohr model. I'm going to show you 2 more examples, a little more complicated. What if, let's do H2O, a common one, water. Here's my oxygen. When I look at my periodic table, it has 8 electrons. Six, 7, 8. So you can already tell it's going to want to share 2. Hydrogen just has 1. So, like the formula says, there are 2 hydrogens. It's because you're going to try and fill these 2 extra spots. So I'm going to draw hydrogen in green just to demonstrate this a little better. So hydrogen's 1 electron is now shared in the valence shell of oxygen. That's quite light. Can you see that okay? Okay, there's my hydrogen. The shells are overlapping. And here is another one here with its shell and its valence electron overlapping. So now hydrogen's stable because it only has the 1 shell, which remember is full with 2 electrons. And oxygen has 8 in its outside shell. So those are both happy. Okay, now with covalent bonds, you can share more than 2 electrons. You could actually share, you could have something called a double bond. And that happens when you share more than 1 pair of electrons. So if you have, oxygen is another diatomic molecule. It always travels with a friend. So if we were going to draw two oxygens, drawn an oxygen there. Actually, no, let's draw sulfur oxide so I can show you two. Okay, so sulfur and oxygen. Here's sulfur. It has 16 electrons. 1, 2, 3, 4. Oops, sorry. The first shell only has 2. I got ahead of myself. 1, 2, 3, 4. I hope you were looking at your screen and saying, no, Miss Fulton, don't do that. Okay. All right, so the outside one is going to have 6. Okay. Do I have 16? Yes, I do. Do I have room for oxygen? Yeah. Okay, oxygen I will draw in, let's do blue and see if that's easy enough for you to see. No, that's very light. Do red. That's better. Okay. So oxygen has 2. Okay, so you can see here, sulfur wants 2 more electrons to have a full shell. Oxygen also does. So they're gonna basically, they're forming a double bond by sharing all of those electrons. So the way you draw this in Bohr, it's a little tricky, but you draw your shells overlapping. So here, so shell from sulfur. Here is my shell, the outer shell of oxygen. Okay, see how they're touching? And let me just redraw so that my pair of electrons is over here. So sulfur, that's its electron arrangement. There's 6 in its outer shell. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Okay, so to show how this electron and this electron are shared, what we actually do instead of doing that is we're going to overlap the shells so that you can see both shells. So it looks like this. So now, can you see how there's, maybe I'll make it a little bit bigger. Do you see how they're overlapping? So we do 1 from oxygen, 2 from oxygen, 1 from the sulfur that was there, and this one will also move up here. So I'm going to move this closer so you can see better. You show your shells, the outside shells overlapping. Okay. All right.